are utilized in the manufacturing of chemicals and pharmaceuticals. So general types of petrochemicals are aliphatic compounds such as paraffin and isoparaffin, aromatic compounds, inorganic compounds, and synthesis gas derived from petroleum natural gas and crude oil. For natural gas, which produce methane, ethane, propane, and butane, and for the crude oil, which produce methane, saturated hydrocarbons, and benzenes, are the primary suppliers of the raw materials. Hydrogen from methane. Refinery operation depends on catalytic reforming for hydrogen. Steam methane reforming is a great option to provide more hydrogen. Methanol also is made from synthesis gas and can be produced to methanol, to gasoline, to olefins, and to chlorinated product. Methanol can be produced to gasoline and olefins by so methanol is dehydrated to give dimethyl ether, then dehydrated along with methanol over a zeolite catalyst to yield an organic product such as paraffin, naphthalene, and aromatics. For formaldehyde can be produced by non-catalytic oxidation of methanol or by dehydrogenation of methanol by catalytic oxidation using an iron molybdenum oxide catalyst with 99% conversion. Methanol to chlorinated methane. So various chlorinated methane such as methyl chloride, methylene dichloride, and chloroform can be produced by reaction of methanol with concentrated hydrochloric acid catalyzed by zinc chloride by heat. Ammonia production from natural gas or methane, like methane. The first step in ammonia synthesis is to produce hydrogen, usually from natural gas like methane. If present, hydrogen sulfide is first removed from natural gas by amine absorption. Then organic sulfur compounds undergo catalytic hydrogenation, which converts them to gaseous hydrogen sulfide like this reaction. Next, the gaseous hydrogen sulfide is absorbed and removed by passing it through baths of zinc oxide, where it's converted to solid zinc sulfide based on this reaction. Notes: ammonia can be transported as anhydrous liquid ammonia, which boils at 33 degrees Celsius. Hence, it must be cool. It must be kept cool and under modest pressure. Ammonia is used primarily for fertilizer. Anhydrous ammonia can be applied directly to soil. Alternatively, ammonia can be converted to ammonium nitrate or urea and blend with other compounds to make solid or aqueous fertilizer with defined ratios of nitrogen, potassium, and phosphorus. Ammonia to nitric acid by Oswald process. Anhydrous ammonia is oxidation to nitric oxide in the presence of platinum or rhodium catalyst at a high temperature of about 230 degrees Celsius and a pressure of 9 bar. For production of urea from ammonia, also known as carbamide, and from ammonia is carried out by two steps. In the first steps, liquid ammonia reacts with dry ice to form ammonium carbamide in an exothermic reaction. And the second step is ammonia carbamide is decomposed into urea and water under an endothermic reaction. Methane to acetylene. Acetylene can be produced by the hydrolysis of calcium carbide. The heat generated in the initial combustion is used to break the carbon-hydrogen bonds of methane for the formation of acetylene. Phenyl chloride from acetylene and polyphenyl chlorides or PVC. Phenyl chloride can be produced from acetylene and hydrogen chloride using mercury chloride as a catalyst. PVC is made from phenyl chloride, a product of the reaction between ethylene with oxygen and hydrogen chloride over a copper catalyst. Chloroprene from acetylene. In the production of chloroprene, methane is partially oxidized to acetylene. Acetylene is dimerized to give vinyl acetylene, which is then combined with hydrogen chloride to avoid 4-chloro 1,2-butadiene. Chloropane is the monomer source of polychloropane known as neoprene. Neoprene rubber resists degradation from sun, ozone, and water and perform well in the contact with oils and chemicals. Maybe Yasmin can continue the presentation.
Okay, so formaldehyde is produced industrially by the catalytic oxidation of methanol. In the commonly used Formox process, formaldehyde is produced by reacting methanol with oxygen at 250 to 400 degrees Celsius in presence of iron oxide in combination with molybdenum or vanadium. Production of hydrogen cyanide. The most important process for producing hydrogen cyanide is the reaction of methane and ammonia in the presence of oxygen at about 1,200 degrees Celsius over a PT catalyst, and that's called androsyl oxidation. Chlorine solvents, vinyl chloride, and vinyl acetate. Methyl chloride, methylene dichloride, chloroform, and carbon tetrachloride can be produced from the reactions of methane with chlorine. They can also be produced from methanol, as mentioned above, and the reaction of acetylene with chlorine produces chloroacetylenes. Acetylene can also react with hydrogen chlorine or acetic acid to form vinyl chloride and vinyl acetate. Ethane and ethylene. The major component of natural gas is methane, accompanied by natural gas liquids such as ethane, propane, butane, and natural gasoline. The components of natural gas liquids are separated in a gas processing plant through absorption, condensation, fractionation, or other methods. Once the ethane is separated, it is shipped by pipelines to a cracker facility, which is a very sophisticated series of processes that convert the ethane to ethylene. The first step entails using steam to transport ethane or a mixture of ethane with a small amount of propane to a series of cracking furnaces, where it is heated to approximately 1,500 Fahrenheit. Typically, ethylene comprises about 80% of the total product. Polyethylenes. After purification, ethylene goes from the cracker facility to a nearby complex in which it undergoes polymerization to polyethylene. Products range from grocery bags, plastic bottles, and plastic toys to sophisticated high-tech military helmets. In addition to conventional plastics, polymers can be thermoplastics, thermosets, elastomers, rubbers, and fibers. Thermoplastics can be shaped and molded easily when heated, and they melt when they are not hot enough. When they're hot enough. Ethylene oxide, ethylene glycol, and polyethylene glycol, polyethylene oxide. If oxygen is added to ethylene, it reacts to form ethylene oxide. Ethylene oxide is used to make surfactants and detergents in the manufacturing supply chain of cleaning products. To take it even further, if water is added to ethylene oxide, it reacts in a further process called hydrolysis, which forms the product ethylene glycol. Ethylene glycol is used as an ingredient in antifreeze. Polyethylene glycol is produced by the interaction of ethylene oxide with water. Ethylene glycol or ethylene glycol oligomers catalyzed by either acidic or basic catalysts. And the catalysts are magnesium, aluminum, or calcium organoelement compounds. Maybe someone else can continue.
Maybe I can continue the presentation. Phenyl acetate and polyphenyl acetate, or PPA. Phenyl acetate can be polymerized to give PPA. PPA emulsion in water are used as adhesive for porous materials. Phenyl chloride and polyphenyl chloride, or PVC. Phenyl chloride is made from ethylene, oxygen, and hydrogen chloride over a copper chloride catalyst. It can also be produced by ethylene with chlorine over an iron chloride catalyst, or by thermal cracking of ethylene dichloride. Propane, butane, and propylene and butylenes. Methane, propane, and butanes, or normal butane and isobutane, are separated in a gas processing plant through a fractionation train consisting of three distillation towers in a series, namely a detanizer, a depropanizer, and a debutanizer. Propane and butanes are byproducts of natural gas processing and petroleum refining. The processing of natural gas involved the removal of non-methane natural gas liquids, including ethane, propane, butane, condensate, and natural gasoline from the raw natural gas. Propane can be liquefied as liquefied petroleum gas and sold in the market for heating, lighting, and cooking. Propylene can be made from the hydrogenation of propane with hydrogen as a byproduct. A mixture of butylene is a byproduct of steam cracking of naphtha or gas oils in the manufacture of ethylene. Maybe someone can continue the presentation.
Okay, so for in the next few slides, a description of the chemicals produced from propylene and butylenes and isobutylene will be presented. Okay, so here is the first four. There is first polypropylene PP, which is also known as polypropene, is the second most used thermoplastic polymer after polyethylene. The structure of polypropylene has a similar backbone as polyethylene with the methyl groups attached to every other carbon. And then there is the second one, which is ethylene propylene, EP. The polymerization of ethylene and propylene together produces ethylene propylene EP, or EPM, copolymer, or ethylene propylene rubber. They can also be in combustion with a diene, about 5%, usually ethylene, norbornene, or 1,4-hexadiene to make EPDM thermopolymer. No, I mean thermopolymer. And the third one is isopropyl alcohol and acetone. Isopropyl alcohol is easily synthesized from this reaction of propylene with sulfuric acid followed by hydrolysis of isopropyl sulfate. IPA can also be produced from reacting propylene with water, either in gas phase or liquid phase at high pressure over a solid or supported catalyst. And then for the last one in this slide is cumene to acetone and phenol. Cumene, also known as isopropyl benzene, is produced commercially by Ferroclav's alkylation of benzene with propylene using H3PO4 as a catalyst. It is a building block to manufacture other chemicals such as phenol, acetone, acetophenone, and methylsterenes. So here are the next four. The first one is acrylic acid and acrylene. Acrylic acid is produced by two stages of vapor oxidation of propylene over catalyst. In the first stage, propylene is oxidized to acrylene over a highly active and very selective catalyst, either vanadium or MO oxides. In the second stage, acrylene is further oxidized over a COMO catalyst at 200 degrees Celsius to 200 degrees Celsius. And then the second one we have is nonylphenols, which is alkyl phenyls. Propylene can be oligomerized to trimers, tetramers, and other olefins in the presence of acids. They're used in manufacturing antioxidants, lubricating oil additives, and detergents, emulsifiers, cosmetics, and insecticides. The third one is dodecylbenzene and linear alkyl benzenes. Dodicyl benzenes and some related linear alkyl benzenes are produced industrially by alkylation of benzene with dodecane, propylene tetramer, and also corresponding linear monoolefins in the presence of hydrogen fluoride, aluminium chloride, or related acid catalyst. The fourth one is alkyl chloride, which is epichlorohydrin and glycerol. No, there's just three of them. So this alkyl chloride is produced by the chlorination of propylene. At lower temperature, the main product is 1,2-dichloropropane, but at high temperature, 500 degrees Celsius, alkyl chloride is predominant through a free radical reaction. Next, we have acrylonitrile and acetonitrile. Most industrial acrylonitrile is produced by catalytic oxidation of propylene known as Sohio process with acetonitrile and hydrogen cyanide as byproducts. ACN is usually used mainly as a monomer or a co-monomer in the production of synthetic fibers, plastics, and elastomers. And we have uh, butylaldehyde, butanol, and 2-ethyl hexyl alcohol. Higher carbon number alcohols can be manufactured from lower carbon number olefins with carbon monoxide and hydrogen through hydroformulation by the oxo process. And then we have polybutanes. Polybutanes. So isotactic polybutylene 1 PB1, as in the case for isotactic propylene and other polyolefin, is synthesized commercially using two types of heterogeneous Ziegler-Natta catalyst. And polybutylenes are used in piping system, plastic packaging, hot melt adhesives, and like etc. So for the last three, we have polyisobutylene. In the industry today, polyisobutylene are produced by ionic polymerization of the monomer isobutylene at temperatures from minus 80 to 100 minus 100 degrees Celsius. They are processed using the ordinary equipment of the rubber industry. PIV are used for electrical insulation and as anti-corrosion coatings and adhesives and etc. For butyl, chlorobutyl, and bromobutyl rubbers, butyl rubber is a copolymer of isobutylene with isoprene produced by polymerization of about 98% of isobutylene with about 2% of isoprene for cross-linking by vulcanization. The PIB and butyl rubber are also used in adhesives, agriculture, chemicals, fiber optic compounds, and etc. And for the last one, we have butadiene. 1,3-butadiene is a byproduct in steam cracking of liquid hydrocarbon mixtures to produce ethylene and other light olefins. Most butadienes are produced or polymerized to polyisobutylene and with other co-monomers to produce tough and or elastic synthetic rubber. For the next slide, maybe someone else can present.
So for the next part, we have hydroformulation, which is an oxo process. Hydroformulation is also known as oxosynthesis or process. It is an industrial process entailing net addition of the formyl group and hydrogen atom to a carbon-carbon bond. Thus, it converts linear one olefins to aldehydes and alcohol. Hydroformulation is an important process in the making plasticizers for plastics and long alkyl alcohol for detergents and surfactants. Next. And then we have butanols and methyl ethyl ketone, which is MEK, which is they are the most common process in the making of butanol starts with propylene, which undergoes hydroformylation to form normal and isobutyraldehydes, which are then reduced with an hydrogen to 1-butanol or N or 2-butanol. Butanol is considered as a potential biofuel, and butanol are used as solvents in a variety of textile processes and many industrial applications. Normal butanol is a solvent for paints, resins, and other coatings. Next, we have the Btx derivative. In refineries, in addition to hydrogen and other products, catalytic reforming generates benzene, toluenes, and silenes, and ethylbenzene. The reactions of benzene with propylene yield cumene, which produce a mixture of acetone and phenol via a common peroxide. The condensation of phenol and acetone in a 2:1 mole ratio produces a bisphenol A. Nonylphenol is produced by the acid-catalyzed alkylation of phenol with a mixture of nones. Partial hydrogenation of phenol or hydrogenation of benzene gives cyclohexane, which yields cyclohexanol and cyclohexanone upon oxidation. In the Btx derivative, we have three types of derivative. The first one, we have the benzene derivative, which is the reaction of benzene with propylene yield cumene, which produces a mixture of acetone and phenol via cumene peroxide. And then the second one, we have the toluene derivative. And lastly, we have the silenes derivative, which are there are three and isomers artemethan para, and which the most valuable is pyrethylene, which undergoes oxidation to form terephthalate acid. For the first one, the benzene derivative, we have three types of materials. For the first one, we have nylons, which is a thermoplastic, silky material and was the first commercially successful synthetic thermoplastic polymer produced by DuPont at the 1930s. Uh, Nylon 66 is made by reacting adipic acid with hexamethylenediamine that can be found at significant commercial applications in fiber. And for the second part, the toluene derivative, we have three examples, which is we have the TNT, which is the trinitotoluene, specifically with 2, 4, and 6 trinitrotoluene. Is the best known as an explosive material. Its explosive yield is considered to be the standard measures of bombs and other explosives. In industry, TNT is produced in a three-step process. The next one we have the TDI, which is a which is a toluene dissociates. This TDI has like 6 possible polymers. Two of them are commercially important, which is the 2.4 TDI and the 2.6 TDI. The TDIs are important to building blocks to produce polyurethanes by reacting with hydroxy groups, such as a wide range of polyols. And then the last one, we have the Toluene Disproportionation, which is it is said to occur when a reactant is transformed into two or more dissimilar products in the UOP Tatarei process. For example, toluene is converted by a disproportionation into benzene and silenes, as shown. The process also achieves transalkylations of C9 to C6 aromatics to form additional benzene and silane. Next, we have the synthesis gas or syngas. As mentioned, synthesis gas is a mixture of carbon dioxide and hydrogen, and very often some carbon dioxide. CO is produced commercially by a partial oxidation of natural gas, coal, or biomass. Both CO and H2 can be produced by steam or methane or naphtha reforming. Additional H2 can be obtained
from the water-gas shift reaction with CO2 as a byproduct. The main use of syngas is to produce alkanes, olefins, and alcohols through the Fischer-Tropsch process, and in South America during the apartheid, when due to an embargo in the country could not import enough petroleum to meet its ends, syngas from coal was the main source of commercial hydrocarbons. And in the syngas part, we have three examples, which is three types of process. The first one, we have the Fischer-Tropsch process, which is the liquid transportation hydrocarbon fuels and various other chemical products can be produced from syngas via this process. This process involves a series of chemical reactions that produce a variety of hydrocarbons. It starts with the partial oxidation of methane and or other hydrocarbons. The second one, we have the syngas to gasoline plus process. This process consists of four fixed bed reactors in a series with syngas and converted to synthetic fuels. For producing high-octane gasoline, syngas is fed into the first reaction to convert most of the syngas to methanol by passing through the catalyst bed. And next one, we have the syngas to methanol, where methanol is produced when the CO and CO2 produced in the steam methane reforming and water shift reactions are reacted with hydrogen in a ratio of 5 by 5 by 90 at 50 to 100 bars and 225 until 275 Celsius over a few catalysts. About 40 of the methanol is converted into formaldehyde and from there into diverse products. Next, we have the integrated gasification combined cycle or IGCC, where, as mentioned, syngas can also be produced from integration gasification combined cycle, where a high-pressure gasifier with a sub-stoichiometric oxygen turns heavy petroleum residue, coal, and biomass into pressurized gas. The syngas and hydrogen are used for power generation to drive generators rather than making chemicals. The IGCC plant is called integrated because the syngas is produced and the gasifier is used as a fuel for the gas turbine. And secondly, the steam generated by the syngas cooler in the gasifier is used to drive a steam turbine in the combined cycle for electricity generation. A third function is sometimes added, which is the cogeneration of hydrogen for refineries and other industrial facilities. Um, for this part, if I wasn't wrong, the title was supposed to be the hubungan between refineries and petrochemicals. I'm sorry for the mistake. And for that part, it is explains that refineries supply several feedstocks for petrochemical plants, which primary petrochemicals can be divided into three groups: olefins, aromatic, and synthesis gas. As mentioned, olefins are a major source of polyolefins such as polyethylene, polypropylene, and ethylene. Ethylene and propylene are source of other polymers too. It's a two-way street where petrochemical plants also feeds refineries. The olefin plant is essentially a steam cracking plant to produce olefins. Hydrogen is, for the most part, a byproduct of olefins plants, but it has a high value in refineries. Shell development is providing manufacturers with an unprecedented opportunity in low energy, but however, that is the only part of the picture. Maybe that's all for today's presentation. Thank you all for your time and attention. Uh, thank you.
Halo, kuliahnya sudah selesai tadi ya presentasinya ya?
Sudah selesai, Prof.
Oh iya, mohon maaf tadi saya hilang ininya jaringannya. Baik kalau gitu, oke, thank you very much ya. So, I think the presentation is very nice and complete. So, I think first start from the 7 it's long time. I think we can end it the lecture for today. Very much for group 3 and group 4, and then we will see again next week. For the discussion, I think will be conducted in next week. Yeah. Thank you very much. Goodbye.
Terima kasih, Pak.
Ya, sama-sama.